Hello, we are Rogue Squadron. We, over the course of this semester or the school year, have been working with Vertiv in order to solve the server door problem. We are using a facial recognition system in order to open and close a server door. Our facial recognition system provides security, preventing people who can or cannot come into the room or come into the server door, and also reliability.
So, a summary of our project would be a fairly robust system that combines a Raspberry Pi and a variety of hardware components. And this provides an expedient and low power solution because all of our components fall into a power budget that we've set for ourselves, and also the system is in a perpetual state of standby as long as there's no face in the frame. And we had to take this into consideration because we didn't want to consume too much power. But during our actual calculations, we determined that having this in a perpetual state of standby would not actually consume a tremendous amount of power. So this allows the system to do most of the work and requires very little on part of the user except for being present, which thus creates a very expedient and efficient way to secure the server rack door.
So for some of our hardware features, we did choose to use a Raspberry Pi. The Pi was chosen because its performance was superior to the Arduino. And because of that, we did end up having to use a 3.3 volt to 5 volt logic shifter since the Raspberry Pi uses a 3.3 GPIO pin. And with that, the outputs from that GPIO pin would have gone to our relays. These relays were literally just in place to make sure that no improper signals or interference got to our actuators and caused them to actuate or deactivate at the wrong time. For user feedback, in this case, we just used an LED. They would flash different colors. In this case, red, basically saying that it was locked, white for general error, green saying that your face is recognized and the door is open, and yellow just to show it's processing. So when you close the door, we just have a push button that you press, and it'll lock the door and return basically to state red. And in this case, we just used two actuators. That's all we felt that were necessary. One at the top of the door and one at the bottom. They're both just 5 volt pull actuators, so they were very simple, and they helped us maintain our power budget.
So for this project, we had numerous software features. The first and foremost being that it's written in Python. This allows a lot of greater flexibility in terms of the complication for the developer. One of the things we did was we had a separate module in Python for that LED that we call as a separate process, so that it can run infinitely. And because we encountered problems where the software would just stop on its own because it reached the end of the module, so we called it as a separate infinitely executing child process. Another thing too, and the single most important thing, is that this project does not accept anything other than human faces. So if you walk up with your cat, which has been tested, or if you walk up with like a potted plant, it's not going to work. It has to accept a human face. And another thing that's very, very important is that the entire project is contingent on access to the person's eyes. So if you're wearing normal glasses, no problem. But if you walk up wearing sunglasses trying to obscure your face, it won't accept it.